In this video, we're going to talk about a very specific theorem, which is the triangle side splitter theorem. All this theorem says is that if I have a segment which joins the midpoints of two sides of a triangle, like so, that segment will end up being parallel to the third side. So this segment is parallel to the third side, and its length is actually 1/2 the distance of that third side. Now, if we were to use this theorem in a proof, we would represent it by the triangle side splitter theorem, and that's our notation. So let's see an example of how it could actually be used in a proof. So in my proof, given that x, y, and z are all midpoints of their respective sides AB, AC, and BC, I need to prove that AXZY, this piece in the middle, is a parallelogram. Well, we're actually going to use this triangle side splitter theorem in the course of this example. So first, let me label all my given information. I have that x is a midpoint of side AB. So I'm going to label that in my diagram. And I also have that y is a midpoint of side AC. So therefore, since it's a midpoint, it cuts those segments into two congruent parts. And finally, z is the midpoint of BC. Okay, so let's label that given information in our proof. X, y, and z are the midpoints of AB, AC, and BC, respectively. That's given. Okay. Well, you may have already figured out how we're going to use the triangle side splitter theorem. But if not, let me point out that since XZ is the segment that connects the midpoints of two sides of a triangle, it's going to be parallel to the third side and equal to 1/2 its length. Now, in this particular case, I'm trying to prove something's a parallelogram, so I'm not going to be too interested in the second portion of the theorem, which talks about it being 1/2 its length. I'm going to mention specifically that side XZ has to be parallel to AC by the triangle side splitter theorem. At the same time, similarly, I'm going to point out that because segment ZY connects the midpoints of two sides of a triangle, it will also be parallel to the third side by the same theorem, the triangle side splitter theorem. So I can mention that in the same step, that YZ is parallel to AB. Well, since XA is a segment contained within that line, XA will be parallel to YZ, which is one of the sides of the shapes I'm trying to prove is a parallelogram. So AX is parallel to YZ. And similarly, AY will be parallel to XZ because AY is a portion of segment AC. So the reason these sides are parallel to each other is that segments contained within parallel lines are parallel. So that now I have two sets of opposite parallel sides in my quadrilateral AXZY. Therefore, AXZY is a parallelogram by the definition of parallelogram. Okay, so that's how we could use this theorem, this triangle side splitter theorem, in a proof. Now notice I didn't use the fact that it's half the distance of the third side anywhere. Well, that tends to come up more in algebraic examples. So there's an example of that just below. Given, in this case, that S and T are the midpoints of PR and QR, respectively, meaning that S is the midpoint of PR and T is the midpoint of QR, we need to find the value of X in each of these examples. Well, let's do the first one together. It says that ST is 3x, so it has length 3x, and it says that PQ has length 24. This is question A. Well, the triangle side splitter theorem tells me that a segment which connects the midpoints of two sides of a triangle has a length equal to 1/2 that of the third side. So I can set up an equation using that theorem. The length of ST has to equal 1/2 the length of the third side of this triangle, which is 24. Therefore, 3x is equal to 12. And when I divide both sides by 3, I end up with x is equal to 4. Okay, so there are 3 other examples here. I would like you to try those examples on your own, and we will go over them in class tomorrow.